we think we're all talking about the same things, but often we're just sort of using the same words, right? And maybe often reaching similar understandings, but underneath there's this vast variability. It always struck me as strange to think that, okay, if you have no grounding to the external world, you can't have any meaning at all. But then, okay, how much grounding do you need? Like, if you put in a little bit, now suddenly everything is grounded out, and then meaning just magically appears? That doesn't seem right. It doesn't really make sense that you can take a thought and beam it into someone's brain, right, and have that thought make sense to the other person. But of course, with language, that's kind of how it is.
This is Brain Inspired. I'm Paul. Welcome, everyone. My guest today is Gary Lupyan, who runs the Lupyan Lab at University of Wisconsin-Madison, where he studies how language and cognition are related. In some ways, this is a continuation of the conversation I had last episode with Eli Pavlik, in that we partly continue to discuss large language models. But Gary is more focused on how language and naming things, categorizing things, how that changes our cognition related to those things. How does naming something change our perception of it, and so on. He's interested in how concepts come about, how they map onto language. So we talk about some of his work and ideas related to those topics, and we actually begin the discussion with some of Gary's work related to the variability of individual humans' phenomenal experiences, our subjective experiences, and how that affects our individual cognition. For instance, some people are more visual thinkers, others are more verbal, and there seems to be an appreciable spectrum of differences that Gary is beginning to experimentally test. And of course, we cover a lot more topics related to language and cognition. Show notes for this episode are at braininspired.co/podcast/164. On the website, braininspired.co, you can also learn how to support this podcast to help keep it running. Thank you in advance if you make the decision to take that generous action. Thanks to Gary for being generous with his time, and here he is. So I was in let's call it a disagreement with my wife the other day, and I was tasked with expressing my feelings to her, and of course I failed, as I always do, because they're like ineffable, and words don't really do justice. I felt limited. If I started using words to describe what I was feeling, it was going to limit the actual experience that I had or was having. And I feel, maybe this whole time you can just disabuse me of this notion, I feel that words are limiting in terms of cognition. Yes, they're highly abstract, but they don't capture the essence of what I'm feeling. Feelings are a whole nother bag of tricks here. But why is it that I think that the most interesting things are ineffable and words don't capture, like categorizing it using words is maybe limits it, if that makes sense?
Yeah. The way I tend to think of it is that the currency of language is categories, and that makes it really great for conveying certain types of information and really bad at conveying other types. And so whether language is good for communicating depends on what one's talking about. Now, when it comes to feelings, or for example, faces, some faces are notoriously hard to describe in language, and it's not just a problem of English. No language is good at describing faces, because what distinguishes one face from another, for the most part, is not categorical. And so the best we can do with language is, and this is very telling of how language works, is when it comes to describing a face, is to remind someone of a face that they know, right? And then say, well, it's kind of like this person, but, and then put a little, nudge them in some direction, but older, right? Or friendlier. We're good at interpreting something like friendly. It's interesting that we are good at that in terms of, having some visual appearance. But despite this, we figure out ways, and this is what a lot of, what good writing is about, of conveying things like feelings, visual descriptions, using language. But it's hard. Doing that effectively is hard work. I think of language as a series of cues that we exchange with one ourselves. It's little cues for constructing mental representations. And a lot of what we talk about is actually, it lends itself to kind of categorical cues that language is really about. Yeah, I mean, and my other response is, well, compared to what? So when it comes to conveying our emotions, well, what's the alternative? I mean, you can do a lot with your face, but it doesn't have that sense of being about something in particular, right? So, in many cases, language might be the best we can do, even for conveying kind of ineffable things.
So my wife is not dumber than me just because she uses words to express things that I can't?
I mean, well, no, but is it do you feel like it works? Like,
from her?
Is she able to communicate? Yeah, is she able to communicate
she's
her
like
emotions?
In touch with her feelings, and she's great at it, and I'm terrible at it, and I mean, I think it's an age-old story, but
there's skill in, on your end as well, right? In interpreting it. So she might be really good at it, but like it takes skill to be on the receiving side, on the comprehending side, and actually taking those words and constructing something that is meaningful to you, and presumably, right, even if it's meaningful to you, but it's totally different from what she was intending. Like, we'd say that that's not a totally successful act of communication. But often we can kind of meld our minds in that way with language.
So I just wait it out in deafening silence, and then eventually it goes away. I thought that was the right thing to do. But okay, so we have a ton of stuff that we can talk about. Maybe I'll. I don't know if I want to start with inner speech. I was going to bring this up later. I had Ellie Pavlik on the podcast, and I was telling her that I was going to have you on, and that you're interested in this the phenomenal variability, like the variability in all of our phenomenal subjective experience, and part of that is our inner speech. And I know that you're interested in it. And I was telling her that I feel like when I find myself talking to myself during a task or something, using language in my head, I feel dumb. This is not all about me being dumb, but a good portion of it is. But I feel like, why am I talking to myself? That seems, in the same token, I remember my dad, back when we didn't have iPhones, but there were GPS systems that you could put in your car, and they were specific for GPS, and they would talk to you, and he would talk back to it. And I thought, oh man, that's unfortunate. So, so is inner speech a sign of intelligence, or the opposite? And then we'll talk about variability in our fundamental experience, I suppose.
So I had a paper that I wrote a while ago when I was a postdoc about talking to yourself in the context of visual search. So can repeating the name of something help you find it? And for whatever reason, like a year after it came out, it suddenly started getting all this media attention. And even now, like, I don't know, a dozen years later, like when you Google talking to yourself, like this stuff comes up. And the framing is often, you're not crazy if you talk to yourself, right? Like science has shown. And it gets away from the core narrative. Yeah. It's like, if you talk to yourself, it means you're a genius. It's like, that's not what the paper is about at all. But I think there is, there are two things. There's the actual overtly talking to yourself, and that, at least in our culture, that's discouraged, and that's kind of often seen as like, is there something wrong with this person? Because we expect it to be inhibited, right? And then there is inner speech, right? The kind of covert experience that really a large majority of people have. And one thing I've learned since we started studying it is that, we all tend to think, when we reflect on our experiences, the common thing to do is to think that, well, what we have is the typical thing. And then you realize, that, well, there's a distribution and you're somewhere on it. And so I thought my inner speech was typical, but it seems that it's kind of like on the low end. There are questions that on these questionnaires where like most people put themselves as a 10 on a 1 to 10 scale, like that they do this constantly. And I put myself as something like a 5, but I thought that that's where most people were. So I think intuitively it seems kind of silly. Like, how can you learn something from yourself that you didn't already know? But of course, that's the wrong way to think about it, because there's no central you, right, that knows everything. And that's why, when you're writing, like, everyone seems to have this experience, right? You learn something by writing. It helps you organize your thoughts. And so I think of talking to yourself as a similar type of thing. You're linearizing things. You're making connections that you're obviously capable of making, but may not have made prior to actually kind of pushing it out and back in. So Dan Dennett has this in his Consciousness Explained book. He has this little figure of, I remember the caption, this cognitive autostimulation. And it's like a little schematic brain with like these kind of semi-connected parts. And then, there's an arrow that comes out of the mouth and back into the head, right? Andy Clark has also written a lot about this idea. So, I think of language as a technology, and when we talk to ourselves, whether overtly or covertly, right, we're using that technology, to help ourselves think through things, and it's good for some things, less good at other things.
What is it good? I mean, so I appreciate language as an abstraction, and a lot of your work has shown that labeling things helps you do things faster and helps your cognition about those abstract general concepts. But I feel like the majority of stuff that's at least interesting to me, labeling, one thing about abstraction is it takes away details, right? And so you're kind of simplifying everything to a degree that might hinder thinking about it. And so I'm not sure how to think about this, like where you think the balance is.
Yeah. I think about it being less about removing details and more about highlighting dimensions or details that are relevant for a certain task. So you might, for example, realize that there is a connection between two, say, situations or two processes, that there's some underlying similarity, and it helps you kind of reach some conclusion, draw some inferences that you otherwise wouldn't make. And so you are, in a way, ignoring certain details. I think it's rare that we actually get rid of them. We hang on to lots of things, even if they're not relevant to current task, because they're relevant for other tasks. So, for example, if we have a task of understanding what someone's saying, so knowing what words they're saying, it might not be relevant what their voice sounds like, but you can't help but also attend to the qualities of their voice, because at the same time, like, those things are important for identifying like where they are and where you should turn your head to face them, who they are, and that those kinds of things, can help you can help feed into the meaning, because you have you can deploy different priors depending on the last conversation you had with this person, or what you think this person is likely to know based on the specific jargon they're using, and all of that kind of becomes relevant, even for something as simple as knowing what word is this person saying, right? Going from like the raw speech to some more invariant representation. So so I don't think we're really throwing away the details, but we're weighing different dimensions. And so, I'm happy, by the way, to circle back to inner speech later, because I think there's a lot to be said about that kind of variability and what it means about studying connections between language and cognition.
Okay. I was about to bring us right back to that, because I mean, this kind of ties into the idea of the dimensionality of language, right? So we all have different phenomenal experience, and one way to look at that is that our phenomenal experience is important, and however subtle those differences are, whether or not they make a difference to our cognition is something that you could tell me, and what you've come to think about this. But then I also thought, well, it may be that we all have the same high dimensional stuff going on under the hood, but our phenomenal access to various parts of it differs, and that's what leads to the differences in subjective experience. So maybe you can just elaborate on that.
Yeah.
On that, if that's a ridiculous idea.
No, it's not a ridiculous idea, and it's really an empirical question. There's probably some of both. I mean, that's kind of a boring answer, but so as far as variation in visual imagery, inner speech, there's certainly work suggesting that in some cases the best explanation might be different access. But there's also work showing different performance on objective behavioral tasks. So we find, for example, differences between subjectively reported inner speech, relationship between that, and how well people can judge whether two words rhyme, their kind of what's called verbal working memory. There's also lots of correlations between subjectively reported inner speech and other aspects of subjective experience that we might or might not take at face value. So, for example, earworms, getting songs stuck in your head, very common experience. People who report not really having much inner speech also report that they know what this is about, but they report that this doesn't happen to them very often. Something that, especially in the college student population, this experience of like thinking about a recent conversation you've had and thinking about like, well, maybe I should have said this and that, like, huge endorsement of like, how often does this happen to you? Most people are saying all the time. People with less inner speech are saying, not much. Right.
Well, I missed the. What about the earworm? What was the relation between getting songs stuck in your head and inner speech?
Just that people with less inner speech are less likely to experience it. So I wouldn't say never, okay. But yeah. But there's absolutely value in trying to understand the sort of cognitive profile differences in cognitive profiles using objective assessments. So more of this has been done in the visual imagery realm than in the inner speech realm, and there you find really interesting patterns where, in some cases, you find objective differences. So different patterns of recall and memory, for example, less visual imagery, less details in recall, even when that is the task. Recall in as much detail as you can, some experience. But in other cases, no differences in the kind of gross level performance. But then when you start going deeper into, well, how are people doing the task? What are the correlations between tasks? You find differences suggesting that people are using different strategies. And it's in line with what they report. So it's a case where we should take people's self-report seriously because, they're doing some memory task and you ask them, well, how did you do that? And they tell you how they did that. And it's not how people with typical visual imagery do it. And then you sort of do a follow-up study. Well, if they did it using this kind of strategy, then they should find interference with these types of stimuli. And you find indeed that like the results bear it out. So these differences have consequences. But it's lots and lots of unknowns. Another relevant area is synesthesia, where at one time people thought, people are having these different phenomenal experiences, but they're not really like perceptual. And then it's not that hard to design some actual psychophysics studies to test whether people's attention, for example, is being kind of involuntarily grabbed by, where someone who has various forms of space-time synesthesia, where, thinking about a certain month is associated with a certain part of space. And then you can see that indeed, unlike people who don't report having this phenomenal experience, in the synesthetes, you cue them with a month and their attention kind of automatically goes to that part of space, even when it's completely irrelevant to the task. Yeah.
So what are you thinking in terms of how wide the variability is in our differences between people in their subjective experiences? Is it a subtle thing? Is it a wide landscape?
I think it's relative to our expectation. My hunch is that it's much more than we expect. I stumbled on this video just yesterday. I can't believe I haven't seen this before. It's a bit of Richard Feynman. It's like a 6-minute clip called Ways of Thinking, where he makes this point that, and I'll post a link to it or something. People can watch it themselves.
I'll link to it. Yeah, sure. Yeah.
He talks about kind of how some experiences in his life that led him to think that there is this huge variability in how people kind of experience different types of thought, even when they come to the same conclusion, right? And that we think we're all talking about the same things, but often we're just sort of using the same words, right? And maybe often reaching similar understandings, but underneath there's this vast variability. And it can be studied experimentally. And so one thing that excites me so much is that it really is an empirical question. And I think one angle we've taken is focusing on this hidden aspect where these kinds of variability that seem to exist that people are unaware of. Because there's lots of variability in behavior that we all know, right? We all know that some people go to bed later than other people, morning people. And the reason we know this is we get lots of feedback from the world. We know that people have different food preferences, right? And so there is a tendency even there to think that others are more like you. Like if you like chocolate, you think more people like chocolate than if you personally don't like chocolate, right? But when it comes to these hidden differences, right, like visual imagery, synesthesia, inner speech, one can compare notes. One can study it, but we tend not to. And we just project our own experiences onto the world. And one reason why I think we can keep going around about our life and not realizing that people have these different experiences is that their consequences on behavior are not as big as one would expect. Because there are, it's a more robust system then one can. So if there were lots of things that really, really required vivid visual imagery, then people who didn't have vivid imagery wouldn't be able to do those things. And they know that. But in fact, a lot of the things that we assume require imagery, actually, there are many ways of doing them without the use of imagery. And so it kind of opens the door to studying this diversity of solutions. And we draw in this paper, we have hidden differences. We draw a comparison to what's been called cryptic variation in genetics. That a lot of, you do gene knockouts and you find that for a lot of things, like you don't find any observable effects on behavior. And the question is, why should it be that way? Like, why have this redundancy? And one answer is that, well, you have this redundancy to ensure that different developmental trajectories can all lead to a functioning organism. That if you had to do things in a very, very precise way, you would not have sufficient robustness, basically. And so as a consequence, you find that there are multiple pathways. And so knocking out various genes often doesn't have any consequence because they're just one kind of path of many to getting that development right. And I think of these hidden phenomenal differences as kind of, repeating that same process, but at a higher, at the next level where, okay, you have a functioning organism and you have to, maybe in your culture, learn to read or learn to do math. And well, there are actually many ways of getting there. And so despite different starting points and kind of different trajectories, you can get there, but you don't necessarily do it in the same way.
I had Dean Buonamano on the podcast a long time ago, and I don't remember how, but I later learned that he has aphantasia, I believe is the term for it, where he doesn't have any visual imagery. And I think that is so insane to me to be able to think without visual imagery. But that's why I was asking about is it just a matter of whether we're accessing it phenomenally or whether it's actually going on under the hood and we don't really know about it, or I guess this is the multiple realizability issue.
Yeah. I think for certain kinds of questions, the access question might not really matter, right? If the work is being done by the part that we are conscious of, by kind of interacting with the sort of visual images that we consciously experience, then even if at some lower level it's an identical system, right? Not having phenomenal access is what might make the difference.
Well, that's what you're finding, is you're finding these behavioral differences based on whether someone is having phenomenal access to it.
Yeah, exactly. But it's not to say, right, that like these differences in phenomenology need not imply that, the visual processing in some people is fundamentally different. I don't think that's the case.
But okay, yeah. But so would the conclusion be that consciousness has a function?
I think absolutely consciousness has a function. So I sort of reject the zombie thought experiment, right? That logically, of course, we can think of such a creature, but I think someone who is, unconscious without the phenomenon, would not behave in all the same ways. So but I also, on the other hand, I think there's absolutely one could make the mistake in the other direction and put too much weight on conscious experiences, whereas in reality, a lot of these are, post hoc rationalizations, and the reason we do something isn't.
So should I feel okay about having should I be talking to myself more internally or externally or less? What should I be doing?
Well, okay. So one thing that we've been really interested in is the relationship between language, both publicly used language, but also inner speech, and kind of aligning our minds, right? So Andy Clark and I have this little essay in Aeon about telepathy, kind of the thought as a thought experiment, right? And we both have this intuition that it doesn't really make sense that you can take a thought and beam it into someone's brain, right, and have that thought make sense to the other person. But of course, with language, that's kind of how it is, right? We have words that are supposed to denote some sort of thought, and we use them, and then the other person, understands those words are meaningful to the other person to some extent, right? And so if you can beam words from brain to brain, right, that would sort of work, but that's not really telepathy. That's just like fancy texting, right? That's not that interesting. The whole point of telepathy, of the trope of telepathy, is that you can take language out of the loop and be able to communicate with someone who doesn't share your language, with an alien, whatever. Right? And so, we argue that we have no reason to think that this would work, but that language may. It could be that that's the best we have, right? And that it is what allows us to align our mental states sufficiently to achieve at least some level of understanding. And so the idea, there's an experimental angle to this question, which is if people use more language, are they more aligned? And so we do have some preliminary data showing that people who report using more inner speech are more similar in their responses to things, in their similarity judgments. They are sort of more aligned, which is what you would expect given that language is this categorical system. And so if you are kind of thinking more categorically, whatever that means, you're more likely to align because kind of it's easier to align on categories than on particulars. So we're exploring this idea. And so one implication is that in using more inner speech might cause you to sort of align more with other people, which, if you are trying to be wildly original and express some idea that is as new as possible, maybe that's not what you want. If you want to express an idea in a way that can be understandable to the most people, maybe that is what you want. Right? So it depends.
How would this, if we had brain-to-brain interfaces, right? I mean, would that just further I guess, would there be more particulars that were aligned in that case? Or, where we didn't have to, where we had this telepathy, it's not telepathy, it's actual brain-to-brain interfaces to some degree, right?
Yeah. I mean, in this essay, in the second half, sort of explore the idea of, if you just had this kind of as an implant, when you're an infant or something, you grow up with it. Both of us can imagine that, we're really good at taking in new channels of information and just making them work. And so there's lots of work even, with adults on sensory substitution, and just people are very flexible in learning to use these new channels of information. But I think it would be a learning process, just like learning language is this protracted learning process where over time you sort of align with other people and you learn how to use it. And so, this is pure speculation. I think with this sort of brain-to-brain interface, it would be sort of like that, right? Just like we learn to, use the expression on someone's face together with what you're saying to kind of build a larger, more multimodal meaning. So you can imagine adding to that some channel of, a flow of neural information that would help you kind of build rapport and maybe disambiguate certain things, add details to certain things. But the question of, so let's say, right, you want to beam a thought to me about your experience after watching some kind of movie, right? Your experience of that movie is based on all sorts of other memories and other movies and, your likes and dislikes and all of this stuff. And so for that to make sense to me, like, would you, in essence, have to, right, beam all of your memories, right? Because that movie experience is contextualized within everything else. And so an isolated mental state, that's why it wouldn't really have much meaning outside of the context of everything else in your head. And so with language, we can decontextualize it to some extent, but that's why it's hard to communicate about things like feelings, because they're much more embedded.
So, but if I'm describing my experience of a film or something to you, in some sense, it's nice to use language, which is this low-dimensional abstract thing, because instead of imparting my experience, what I'm doing is I'm allowing you to form your own experience based on my low-dimensional description, right? So it's so that you can move through your own world and understand it in your own way, and that way it's kind of special, kind of beautiful. Absolutely. And so Mark Dingemans, also from a few years back, has a nice, I think it's published as a chapter on telepathy, and taking a different angle where a common treatment of telepathy treats it as this sort of a brain dump, right? Like, one person transmits a thought or some series of thoughts to another person, right? Whereas actual communication is this interactive process, and we make meaning together. And there's also something that he studied a lot is conversational repair. So it's not a smooth process. So we ask, and we, raise our eyebrows, and we realize that what we're saying doesn't quite make sense given the flow of the conversation, and we backtrack and we say, and that's an inherent part of kind of meaning making. And, a single channel kind of direct communication wouldn't work that way. And so, describing a movie, right, you could imagine it as a back and forth, right? And that kind of makes it more of what you're saying. It's sort of, you're interfacing with the other person's background knowledge and experiences, and you tailor the message to them. Yeah. Well, we don't have to perseverate on this, but I keep coming back to this, thought about inner speech and language, and the relation between language and cognition. And wasn't it Albert Einstein? We always have to talk about Einstein. He's the classic example. Wasn't it him that didn't speak until he was 10 or something like that? Like, his language development was super late. Am I wrong about that?
I've heard the same story. I don't know about 10. I feel like it's one of those words for snow examples, where every iteration the number goes up and up.
Yeah.
But yeah, I've heard that too, that he was
50. He was 50 before he started speaking.
50, yeah.
But then I thought, well, he's a good example of someone who I suppose thought very spatially, and he's the go-to for an example of someone who's brilliant, right? And he wasn't fettered by language.
Yeah, natural language is good for certain things, right? And math is not a natural language, right? And so I think there's a reason why math is difficult for us, for most of us, and requires formal instruction, right? There, we can talk more about that later, but it's very, I would say it's very unlike natural language. There is a link between spatial imagery, which is different from kind of static visual imagery, and math. And you see this both in actual studies, but also in just self-reports of many mathematicians talking about the usefulness of spatial imagery, which naively, I think, to many people outside of math might think, oh, what's so spatial about, like, okay, geometry, sure, but what's so spatial about algebra? But all of these have spatial analogs, transformations, and it's very useful often to think about it spatially. So I think one reason why we can be as good at math as at least some of us are, some humans, is that we can rely on our spatial cognition, which presumably evolved for other things and can be kind of hijacked for math. But yes, it's pretty different from language. Yeah.
Yeah. What, total aside, what are you Russian? What is your background?
My background, yeah. So I originally from the then Soviet Union, from Belarus.
Okay, I'm trying to place that slight accent.
Slight accent, I came when I was 9, 10. Whether people can detect it sort of depends on where they're from. Then I lived in New York on the East Coast, so there's probably a bit of that and some of the Russian. Yeah.
Oh, okay.
Yeah.
I think you say cognition like Paul Chisek, and I think he has some Slavic cognition, which is
cognition.
I always say cognition, so I don't know. Maybe I'll start saying cognition.
Cognition. Yeah. Funny.
Okay. Yeah. These are the important, hard-hitting questions. You trained under Jay McClelland.
Yes.
And he must be delighted about these large language models and their abilities and people's excitement about trying to look for somewhat symbolic and conceptual forms of representation in these models. I don't know. Are you still in touch with him?
Occasionally, yeah. I mean, when I reach out, he's great at responding. And if I'm in the area, I try to see him. My in-laws are in the Santa Cruz area, so I'm over there, at least before the pandemic, was over there more regularly, and so we've met up, and but it's fun to see all that's been happening. Compare that to my grad school experiences.
Yeah. Like it's almost like so you're part of a large body of people who are playing with these large language models, and I don't know if you're trying to trick them or what your angle is, but what is your view on large language models in general? And then I'm curious whether the success of these language models have altered your thinking at all about language and cognition.
Yes. Well, first, my general sense is that of excitement, and okay. I'm kind of giddy.
Are you?
And well, just because it's so cool to see it. It's also tinged with some frustration, which probably other folks on the podcast have also voiced, right? That there is this predominantly engineering approach to them, and I think that's it's effective. These sort of benchmarks and these it's been very effective at improving performance, but it's come at the cost of efforts into kind of using them to do science. And I think it's not because we can't; it's because so much effort has been focused on having the bolded line in the tables, beating the benchmark, beating the previous result.
Right.
Yeah. So, but yeah, I mean, when I was in grad school, Jay, we used neural nets to gain insight. The focus is to use them as scientific tools, and they were toy models. They couldn't do anything, and the symbolic models at the time, I felt didn't give much insight, but they could do stuff, right? If you want a model of poker, right, there was no connectionist model of poker, or even model of driving. Not really. Like if you wanted a program to drive a car, you have to do it symbolically, right? And so it's now kind of flipped, right? Where the models that work really, really well in many contexts, at least, are not the symbolic ones. So that's been an interesting reversal.
So there are still people calling for neuro-symbolic AI. I mean, do you think that is a past concern now, and that we can just solve everything with scale and neural nets?
I think probably not scale, but I think it depends on what question one is trying to answer, right? So, for example, speaking a little bit for Jay, for a long time now, he's been very interested in math and how people do math. So math is at a certain level is obviously symbolic, but his question, and it resonates with also with the way that I approach this, although I haven't been studying math at all, is, okay, we have this neural network of a brain, and somehow we're able to do something like, symbolic computation, algebra, right? I would say that we're not very good at it, but of course, like compared to other animals, like we are, right? And some of us are really, really good at it, and we can invent machines that are even better at it, but like we did the inventing. And so we absolutely want to understand how this emerges from a neural network. And so understanding the emergence of symbolic or symbolic-like behavior is I think a really important goal. But if you, like, what's unsatisfying is if you kind of get to start with all the symbols, if you just build it in, right? And so, you can add a calculator to ChatGPT and have it detect anytime you're asking a question that involves arithmetic. Just plug in the calculator and it would work much better than trying to learn, math from language. But like that wouldn't be that interesting scientifically. So I think if you're going to focus on things where our cognition is most symbol-like, that's great as a research question. But I think you want to try to understand how that emerges from neural networks, but not necessarily from just ingesting data, right? Like, to a large extent, I'd say that the most symbolic parts of our thinking are those that are formally taught. And this is a controversial statement. Many people don't agree with this. I would defend that statement that, things like formal logic, yes, we can do it. We're not that good at it. It's stuff that we are taught how to do. And part of that teaching, I think, involves kind of mapping between, the things that we are good at and trying to use those for doing these kind of, I would say, less natural operations, right? So, it's striking, right? A really simple electronic circuit can do arithmetic much better than our, huge brain. But in learning how to do arithmetic, right, we learn little algorithms and tricks, and also, of course, writing things down on paper to overcome the limitations of our working memory and so on, and be able to do that despite that. But most of us wouldn't discover that on our own. So, yeah.
Yeah, that's one of the most useful parts of language, I suppose. Are you an extended cognition advocate, a la Andy Clark?
I mean, depends. I find, yes. I think in okay. For the most part, yeah. I mean, it depends on, well, what you mean by that. But I think it's absolutely the case, yeah, that we have incorporated all kinds of tools, language being one of them, into just our kind of typical environment. Yeah.
You used the word. Oh, sorry.
Go ahead.
I was going to say, you used the word emergence a few times when talking about symbols. what do you see as the relationship between a symbol and the sub-symbolic entities that give rise to that emergent property? I mean, is a symbol an emergent property of sub-symbolic processes? In a sense, everything is an emergent property. But is that how you think of a symbol, or do you think of it as an abstract, concrete entity?
I think of it as an emergent sort of chunk. So it's been really interesting. So you asked earlier about whether these large language models have kind of changed how I think about anything in language. So one specific thing, and then I'll circle back to the symbol point, is
Sure.
seeing just how much perceptual information seems to be embedded in language. So that, of course, these language models are their only exposure to the world is through language, the pure language models. And yet they come to have all this knowledge about what things look like, spaces, right? Yeah. Navigating through spaces.
That's
and it's
crazy.
It's not hard to find gaps, but that they should know anything at all is remarkable, right? And it's one thing if it's just repeating something it's heard, right? But that's not, I think, what's happening. And there is a very strong analogy here to, for example, Marina Bedny's work on how much congenitally blind people know about the visual world. We have somewhat different takes on sort of the role of language in this process, where she kind of, so it's clear, I think, both of us, that it's coming from language, but she puts more emphasis on the sort of inferential processes than the kind of learning from statistical co-occurrence. And so putting aside the question of whether humans learn all this perceptual stuff from language itself, what the models make clear is that the information is out there, that it can be, in principle, learned from language. And so it's, and I think in many cases, we do, in fact, learn a lot of it from language. For blind people, learning about the visual world through language is one example. But of course, so much of the visual world that we can experience, but we don't, and yet we can talk about it. We have, I would say, real knowledge about things that we've never personally seen, and we learn that through language. And so it kind of, I think, changed my expectation of just how much of this type of information is embedded in language. So that's kind of changed. I think it's changed my view on embodiment a bit. I think prior to this, I would have thought of it as being more central than it is. And there is the question, of course, of, obviously the language that these models are trained on comes from humans who are embodied, and as a result, arguably infuse their language with all of this information about appearances, about moving through the world, about space. And had they not been embodied, of course, the information in language would be different. But that's also true of people learning language, right? So people are learning language from others. And so, it would be different if we found that, models producing language and learning from language produced by other models, right, converge on the same thing. But the point that it's because humans are producing language and that's why the models can succeed is to me a kind of a sterile point, because it's humans are learning language and are learning from language that is produced by other humans as well. So it's I don't know if that totally makes sense, but the idea that we personally, right, must be embodied for this and that bit of language to make sense, I think is in some ways challenged by the success of large language models.
So you just used the term "make sense," which relates to the idea of meaning, and I mean, is one way to think of language so it's its own level of abstraction and connection, and you can learn all the structure and in the world, but are these language models missing meaning, and is embodiment and grounding important for meaning? Of course, well, because the language model, perhaps it's only great at the statistical regularities, right, of language, and that's its own structure. But then the connection to meaning is through embodiment or grounding.
Yeah. So this is obviously a contentious issue, and it depends on what one means by meaning. So it always struck me as strange to think that, okay, if you have no grounding to the external world, you can't have any meaning at all. But then, okay, how much grounding do you need? Like, if you put in a little bit, now suddenly everything is grounded out, and then meaning just magically appears. That doesn't seem right. And then I also find myself reflecting on how people actually use language, and how much of language is pretty abstract and not about concrete things in the world. And so many of the words we use, right, the way that we tend to use them, they might have certain more literal meanings, but the way that we tend to use them really are about the more abstract aspects that are about the word's relationship to other words. In fact, so Mark Brisbane and his colleagues, who collected this large-scale data on concreteness judgments that many people use, so tens of thousands of words, rate this word on a concrete to abstract scale. Here's a little, I think, insufficiently widely known fact about those ratings, which is that the way that they defined whether a word is concrete or abstract is that concrete words are things that, words denoting things that you could point to or enact, right? So jump is fairly concrete in that, you could, if you couldn't use the word jump, you could just like jump around and to convey the idea of jumping. So that's the one end of the scale. And then abstract, they defined as words, meanings of which you would need to describe with other words, right? And so the reason this is important is that when you actually look at the distribution of words that people use, it skews pretty heavily on the abstract end. So these are words that and obviously if in child-directed speech, it's a bit different, it's more concrete. But if we did these few of these little exercises where you take a passage of text and you remove the most concrete words from it, and compare that to removing the most abstract words from it. And removing the most concrete words removes some details. Removing the most abstract words, even just focusing on content words, not like the and right? You just have no idea what this is about anymore. So really, so much of meaning is this in these abstract words, which, those meanings are the relations between words. I have personally no trouble in saying that there is a huge amount of real meaning just in those connections.
It depends on what you mean by meaning, I suppose. It always comes back to that.
Yeah. And I think, the way that, for example, language is often studied, let's say word learning in kids, I think reference is overemphasized, in part because it just makes it easier to run the experiments, right? So you study how kids learn, in a lab, a word for some novel object, right? So you have some concrete object. And it's not because most researchers, I think, language development researchers think that that's all there is. It's just that it's more tractable, than to study the more abstract parts of word meaning and how, words become associated with one another. But I think that among other things led to an overemphasis on kind of concrete reference, right, as a key part of meaning.
Do you think that language models have anything to say about the way that language develops in children? Because they learn so differently. And then, so I was talking, I had Ellie Pavlik on recently, and some of her work her conclusion from some of her work is that it's possible that these large language models could kind of learn backwards from humans, right? Where they get the grounding later. I don't know how much grounding they would need, like you were alluding to, but basically learn perfect language, whatever that is, and then get the grounding later. But do you see any way to tie language model, quote unquote, learning to the way that humans learn?
Yeah, so that actually makes a lot of sense to me, that there is a lot of work showing that kids learn, that there's a big concreteness advantage, right? That children's early words are more, they tend to be nouns, they tend to be concrete nouns. When they start learning verbs, they tend to be the more concrete verbs. So there is lots of evidence pointing to the importance of grounding. I don't know if it's really about grounding or about kind of what kids use language for, right? Which is
for getting what they want.
Getting what they want, exactly. And so, they don't need to talk about this sort of stuff, right? That we're talking about now, right? It's for getting what they want, getting attention, right? Getting, and so and so in a sense, I agree on this with Ellie, that it's a kind of a backwards process. It would be interesting to know whether in these language models, I feel like there's probably work on this, there is also a concreteness advantage. So even though there's no, even if there's no reference to the real world, right, more concrete words tend to be used in more predictable contexts, right? They have narrower meanings, and so they're easier to predict. And so if you're just learning through prediction, there's reason to think that would be easier to learn. But as far as parallels, so I mean, it's kind of become a trope that kids don't learn language in anything like the way that models learn. I mean, I think when it comes to language use, that's true. But I think kids are predictive learners. They also, are learning from examples and generalizing from examples. And a lot of kids' early language is very stereotyped, and it's not as creative and productive as is often made out. And when you know the child's environment, and they say something new, I mean, when they start going to school and they're learning from other kids and stuff, it's all you lose track of it. But
how old are your kids? I know you have Sorry.
Yeah. We have two boys. One is turning 3 in a couple months, and one is 5.5, so in kindergarten.
Wow. Okay.
Yeah. So it's been fun to watch, and but I was going to say that earlier on, when they're saying fewer different things, right? You can often kind of track where they got something from, right? It's like, oh yeah, that phrase, that's clearly from this TV show, right? And they're only using this word within this phrase. And then, a month later, right, it branches out, and now, it's being used in a more expanded context. But it's not like they learned this word and from the beginning they have some, full knowledge of how the word is used. And it's really brittle and narrow. And then often, if you ask them, right, often they use words without full understanding of what they're saying.
So do I.
That's a thing. Yeah, exactly. So do we. But we probably have a higher threshold for it. We have some social monitoring, right? We don't want to be called out or anything. Kids don't have that as much. Yeah.
Right.
But I wanted to just briefly return. So the emerging symbols. So I think what's been so interesting for me in watching these language models is just the effectiveness of prediction, right? And I wouldn't want to say that that's all there is to human learning, but I think that that's a lot of what human learning is about. And I think it means something to find that, hey, this process of predicting works really, really well, right? Does that mean, same thing with reinforcement learning, right? Does that mean that there is something, that nature is trying to tell us something, right? If it works really well across a bunch of contexts, right? could it be that it works really well because it's a really good way of solving a bunch of problems, and biological evolution is likely to have found a similar solution? And so when it comes to language learning, of course, predicting the next word or the surrounding words is generally not the point, but it turns out that it's a really good way of learning structure. And so if you start being able to predict things really well, it probably means you've learned some useful internal model, not just of language, but to some extent of the world. And if it turns out that symbols are a useful part of that model, well, you're learning symbols. And so that's kind of how. So yeah, this idea that like, oh, it's just autocomplete, therefore it can't have meaning. I feel like it sort of misses the point, because the goal is not predicting. That's just the loss function. But in trying to predict, that's just a really good way of learning underlying structure. And if you can predict really, really well in lots of other contexts, we call that some degree of understanding, right? So, even if it's hard to talk about.
Yeah. So you don't think that, sorry, this is could be a off the wall question, but you don't think life is necessary for understanding, meaning, etc.?
I don't know. It's kind of above my pay grade. I don't know. Overly philosophical.
Come down on one side or the other, man.
Yeah. So, so far these models are not actual actors, agents, right? They respond to our prompts, right? They're not actually creating anything on their own, and people are. And so, right? So, I don't know. I mean, I find myself often landing on the side of like, I think humans understand far less than we give ourselves credit for, right? And there's way less understanding in us. And so we're probably overestimating our own understanding and underestimating like understanding in these sorts of models. And so, so I think the models are learning certain world models, right? In some of the same ways that we are learning world models, but we have lots of goals, and we are kind of agents in the world, and we effect change, right? In a way that these models don't. And so, like they don't. We sort of make stuff. We make meaning, right? In a way that these models don't, right? They're just responding to our own prompts. And if you get, two models talking to one another, right, it's not very deep, right? Like it's it becomes kind of circular. Of course, lots of our conversations, human to human conversations, aren't very deep either. So yeah.
Speaking of circular, so this is something that I also asked Ellie the other day. So you have these language models; they're generating a bunch of text. They're trained on the corpora of web text, text from the World Wide Web. But then, so they're generating this text. That text is going to go onto the web, and future models are going to be trained by the text that they generate. What effect does that have on us as a society, but also on the nature of the way that language changes and evolves throughout time?
Yeah. I've thought about it. I don't have an answer, right? It seems like it would just kind of create this circularity and probably amplify existing biases. I think there's right? It's fundamentally different from, a chess or Go model playing itself, right? Because that's a closed world with a definite kind of reward function. And so you can learn from exploring this world, and reach new insights. If you're just using language without any connection to anything, I don't see how you can go beyond just kind of reinforcing kind of existing biases. But if you now combine these models with other sources of data, right? Now maybe you can kind of break out of that circularity, right? And so, right, I mean, one can flip that question around and ask, okay, well, how is it that humans are not running into that same problem? Because we are learning language from other people, and then we are producing the training set. And presumably it's because we're also interacting with the larger world, having different experiences and sharing those experiences with one another, right? Inventing new technologies, interacting with those technologies, and disseminating that new stuff to other people. And so we're not just kind of rehashing the same thing over and over and over again.
Yeah, like if I go, I don't know, take up surfing or something, I'm going to learn new vocabulary, but I also might create a new word for when the water is choppy and it's cold and I had a bad run or something, I might call that a blunk or something.
Yeah.
So a language model, I suppose you could build in that generative neologism objective into the language model, but then, man, that'd be scary if it seems like they would run wild and our language would change really quickly.
Yeah. That's a really interesting idea. So I've been very intrigued by lexical innovation, language change. So one way to think about, right? So, we invent words for kind of things that we already know. And I don't think that's right. So that could be true for if someone invents a word, it presumably reflects some idea that they've already had and that they find useful to have a word for. But in general, the words that we encounter are not things that we necessarily already had a concept for. We learn the concept, many concepts, I think, in the course of learning those words, right? And so if that word happens to become a kind of part of our core vocabulary that every speaker has to know, then you have to learn those words just in the process of learning the language. And so you, as a speech community, end up aligning on those concepts. And so I could imagine, these models, through kind of being exposed to way more text than any individual human, right, can kind of build a new chunk and say, okay, well, here's some useful some regularity that is frequent, but doesn't have a word for, is not lexicalized. And, here I'm going to invent this word and then use it in context. And people, many words we learn just passively by kind of reading and encountering them in context, right? And so now, people are exposed to this thing. So that could be kind of cool. I hadn't thought of that before. That's an interesting kind of influence on lexicalization, language change.
What is a concept, and how do you think about it relative to a symbol? So I know a lot of your work is focuses on whether what you were just alluding to. I mean, you've done research on this. The back and forth between concepts and language, and the idea that you espouse is that we don't have these inherent innate concepts and then just map our words onto them, that it's more of an interaction.
Yeah. So I think of concepts, and I should caveat it by recognizing that there are different meanings of concept as used by psychology and philosophy, and so I'm talking about concepts as sort of internal mental entities. So I think of them as just mental representations of categories, right? And so they're not, and again, with symbol, different people use symbol differently, right? One distinction between how at least some people use symbol and how I use concept is a concept isn't a singular kind of undifferentiated node, right? So it's perfectly sensible for me to say, okay, you have a concept of a dog, but then some dogs are typical dogs and other dogs are kind of atypical dogs. And, some dogs look more similar to cats, and other dogs, look very different from cats, right? So it's not like it doesn't require some single node that is the dog, right?
Mm-hmm.
Dog, in all caps. But there's a sense in which we can have a thought about dogs that is somewhat distinct from thoughts about a specific dog, right? And that's something that language is really good at instantiating. So even if a speaker has a specific dog and they're thinking of a specific dog, they use the word dog, right? And it activates a representation in the hearer of a dog that is more abstracted and more categorical than what would be activated by, for example, seeing a specific dog. And so that's kind of, so I think of language as being sort of like a cue or an operator, right, for instantiating a mental state that in some cases, maybe we'd be able to instantiate that mental state even without language. But I think often we wouldn't, even if we could. In practice, we would not, right? And in the course of learning a word for something, we are learning, and then also in using the word regularly, we're learning to instantiate that more categorical mental state. That is one not kind of as focused on a specific experience, a specific exemplar, specific situation.
Sorry, I'm kind of jumping around here, but I have a couple more kind of open-ended broad questions, and then in the last few minutes, I have some questions from Patreon listeners that I'll ask you. How was I going to phrase this? Has the advent of like these large language models changed the way you view language in terms of how special it is? Within the hierarchy of awesome human cognitive abilities, is language still up there? Or, for me, like seeing these language models, it's like, oh, okay, it justifies that language is not that great.
Oh, yeah. So I have the opposite, actually, kind of takeaway, which is it kind of vindicates the idea that there is something really, central, I think, to language. So, for example, it's been really cool to see the generative art models, right? And that's awesome. Like, I think they probably have a whole lot to teach us about actually the nature of visual information, but it's not a coincidence, I think, that they're using language as an interface, right? So you're training them on these captions and images, and one could say, okay, well, of course, we want them to use language because if we want people to use them, right, kind of for them to be useful, like it's helpful to be able to use language to prompt them to produce certain kinds of visual outputs, right? But language is, I think, actually a much more central part of these models, right? Because if I want to generate a piranha riding on a unicycle, okay, and this is something that we can do, well, where did they get that concept of piranha riding, unicycle, right? That doesn't come purely from the visual information. I'd argue that you can't get it from the visual information alone. It comes from training on vision and language. And so language is not just being used as an interface. Language is actually what is, in these models, creating a lot of these categories that we can then deploy, right, and use. It's incredible, actually, the sense of like a fish riding a unicycle and a horse riding a unicycle. It's a different type of riding, right, visually. And it's really cool that it often gets that right. And that's, I think, kind of unexpected. But that sort of verb, ride, right, like that's not in the visual world, right? That's a word meaning. And the models learned it to some extent because it's there, right? And were it not for language, like how do you get riding out of the visual data? Like, I don't know. I don't think there is a way. So it's kind of showing that language is this actually much more central way of organizing information than than one might think. And I don't know. I don't think So, for example, with the older kind of just the regular supervised vision classification models, right, trained on ImageNet or whatever, and you show an image and it tells you that it's a dog or whatever. In my discussions with folks working with these models, I got the sense that they weren't thinking of the language as playing any role, that these are not, in any sense, language models, right? They're just vision models. And of course, to be useful, you wanted to output a verbal label, but that label had nothing to do with language. And I mean, I think that's not really right, because in that supervised learning process, right, you're telling the model that whatever, horses or dogs or whatever, like, are a thing. And that's a lot of what language is telling us also, right? That, were it not for the encounter with these words, it might not occur to you to treat all examples of this thing as having anything in common. And so this guides your learning, and that supervision signal is telling you still have to figure out what they all have in common. You still have to do the learning. The model still has to do that learning. But it's at least telling you that, okay, treat all of these as being the same sort of thing. And here's the signal telling you that, like, which things should be treated as the same. And I think that's a lot of the role that language is playing, natural language in human learning.
But is there any detriment to that? Is there any I'm sorry, I'm pushing you on this. Like, So, I'm kind of playing devil's advocate, but, by throwing out, by only looking at the commonalities and calling everything, all dogs, or whatever, is there any detriment in terms of cognition?
Yeah, for sure. So, I think you see that in sort of the domain of social categories, right? So we learn gender also, right? So we learn these labels, and we sort of tend to then automatically classify people, right, as members of that category, right? And, that has consequences for treating people, right? It doesn't mean you can't then treat them as, or also represent them as an individual, but there's a consequence to initially classifying them. So you see that in what's been called the other race effect, right? That it's harder for people to recognize individuals of the other race. It's not, it's more accurately called the minority race effect, because it's, so the idea is that, in the US, let's say, white faces are a majority group. And so whether you yourself are white or black, that the white faces are the majority group. So if you see a white person, you're less likely to classify them as a white person, because that's just the kind of the default category. And so what's the alternative is to kind of represent them as an individual. You see a member of a minority group, right? If the first kind of classification is that they are a member of this group, it becomes harder to represent the individual details. And when a category, gender category also becomes salient, it doesn't mean that you're only representing that person as a male or female, but it means that you're representing them as a male who is, and connecting it to other details. And so there are consequences, absolutely, and often negative consequences of this sort of categorization.
Okay. So you're giddy about large language models. You're impressed, and but I think I've heard you say that you're not giddy about the idea of artificial general intelligence. So if I have that right, maybe well, do I have that right? And if so, why not? If you're so giddy about these large language models, aren't we just one step away now from AGI?
Well, so I find the talk of AGI to be kind of uninformed, because it assumes a certain, I think, shallow view of what intelligence is, right? That, first of all, they're sort of like, okay, humans are generally intelligent, and so, when will these AI models be generally intelligent? And then this idea that, like, well, there's nothing special about the level of human intelligence, and so once they're on that track, right, one step below human intelligence, then it's just a matter of days before they're at human intelligence and exceeding human intelligence. And I think that reasoning makes sense when applied to some closed class domain, like playing a particular game, right? It's true that there's nothing presumably special about the human level of Go or chess playing. And once you're good enough, you can quickly exceed it. But I think that logic doesn't apply to actual natural intelligence, right? Because, like, we don't have a good way of, some people think they understand human intelligence. I think they're wrong and have been misled by a kind of reliance on intelligence testing and IQ tests, right? Which, at their best, right, maybe can be good at measuring, right, certainly culturally valued skills and ways of thinking, but there's nothing general about it, right? It's just about, like, sure, IQ tests in many contexts are predictive of success in certain types of jobs and so on, because, like, we value certain skills, and so we design tests to test those skills. But what is general? I don't think there's anything general about it. And so I feel like the discussions of AGI are often predicated on the kind of shallow view of human intelligence. And so, I like to kind of think in terms of a thought experiment, right? Where, okay, if you think that there's something about the human brain that gives us general intelligence, or, go back 50,000 years, right? If you observe people, they would not do well on an IQ test, right? And so they have the same brains. Obviously, the cultural technologies are different. They are way better at certain things that now we don't care about, way worse at other things. They're not doing math, they're not doing science, right? The hardware is the same, right? And so would you then conclude that they are not generally intelligent, right? And it just the whole kind of thing doesn't really make much sense to me. And then the thing about, like, so I think these large language models, right, are showing that, yeah, you can learn, for example, to produce all these grammatical sentences from just input. So they have a lot to teach us about, like, what is needed and perhaps not needed to, say, learn language. But so far, right, they're not doing things in the world the way that animals and human and non-human animals are. And it's not clear how good they are at doing things in the world. So I think we're not even at not only are we not kind of at the top of that curve, we're not even, like, really on it yet. Yeah.
But I like that you highlighted the distinction between humans 50,000 years ago, let's say, and today, because so I agree with you. I don't bind to AGI or generality in general, but what it does highlight for me, and what I've been enjoying thinking about recently, is the vast capacity for that range of cognition that our brains endow us with. I'll say our brains,
Yeah.
so I guess that could be controversial for some people, but it's the capacity that is more impressive to me than the actual doing of any one given kind of task or range of tasks. But I don't know if that makes sense to you, or if you agree with that.
Yeah. No, it is amazing. I wonder, right, kind of continuing that thought experiment, if you had to make a prediction based on the behaviors of people 50,000 years ago, right, would these animals, which are anatomically modern humans, right, would they, go to the moon and, be doing modern physics and all this stuff, right? Like, what reason would someone have to make that prediction, confidently?
Right.
Right. I think 50,000 years ago, like, humans are on a very different trajectory from other animals, right? But based on the level of technology and kind of actual, scientific achievements, right? Not, totally different from now. So I don't know. I think I find kind of the discussions of the intelligence within the context of artificial general intelligence to be kind of very narrow and focused on not just the humans of the present, but particular kinds of humans of the present, right? And so valuing very specific types of intelligence and not others. And this guy, yeah. So I
I'll end before I ask you a few like specific Patreon questions. I began with Ellie Pavlik asking her if I had to freeze her for how long she would like me to freeze her and then thaw her out to then like wake up and continue her research career. And that kind of morphed into her. So 7.5 years, because she said in 5 to 10 years, she feels like we'll have a good understanding of how language models work. Where do you think is that too long of an estimate, or do you think that we'll understand how language models work in the near future, far future? How long would you like to be frozen?
I don't think that's actually that's not my primary goal, to understand how language models work. I think that time estimate seems plausible to me, but I'm not sure that understanding how they work, I think it'll be very satisfying. I don't know that it would change much. So
let's
focus say we have
for your own career and goals. How long would you like if you had to be frozen and then wake up and continue asking the questions that you're asking, and I'd be curious. Okay, I'll say 100 years. 100 years. Oh, I like that. All right. Yeah.
Yeah. So I think that'll give an opportunity to see how language has changed in response to all of this technology.
Oh.
I'm really curious, actually, about the use of these language models. Like, some uses strike me as kind of like time saving, but uninteresting. Like, okay, you can write emails faster. Like, okay, Other uses are sort of much more interesting. So, for example, one of the remarkable aspects of these models that I didn't see coming is that so you've been trained on this enormous corpus of data, but you can access very specific things in this precise and kind of, uncanny way, right? So use of these models for indexing information. And so I could imagine people using them more for basically feeding in their individual information. So people have been playing around with this, feeding in their journal entries to these language models, their notes, right? And then having the model use that information, right, when person indexes it, right? So it's not just indexing kind of knowledge at large, it's indexing your own personal knowledge. And so you can imagine interfacing this with, people's, right, so external memories, so photos, recordings, and having that be a much more integral part of our workflow. And that could really transform, right, like, I'm thinking of education, what it means now. Like, even now, right, with all the technology, college students, they're taking notes, right? If they're typing notes, okay, it's easier to search through those notes, but you have to come up with your own, like, ways of organizing. So, but that could all be, presumably, even with current technology, automated, right? And indexed probably in a more effective way than what we do as individuals. And so having all of this available to us and kind of integrated, I could see that feeding back in and kind of making us, smarter, in certain ways. So that could be cool to see how that develops over the next century. So 100 years.
I would kind of be hesitant or scared. 100 years is, things could be so dramatically different that I would worry that I wouldn't be able to function in society. But I like it.
Yeah. I think, honestly, I mean, if the past, if you look at how people get the future wrong, right? When predicting the future, I think there is a systematic bias, right? Like, people's predictions of technology, some of them are pretty good, but people tend to really underestimate social change, right? So you have, like, Victorian era predictions of, like, okay, flying things, we have flying things, okay. But then it's like everyone is still dressed the same way, and there are, like, traditional gender roles, that has not changed. But now, like, the mailman flies around, right? Like, so I think the hardest things to adjust to will probably be the social things.
Gary, thank you so much for dancing around so many of these topics with me. Before I let you go, you have a kind of a psychedelic, I can tell it's a brain on your shirt. It looks like a cool shirt. Can I see what is the shirt? What is that?
What is the
it's
shirt?
Just brain.
It's a figure 1 brain map. So there used to be this site called Woot. It was bought up by Amazon at some point, and they kind of disassembled it. But they had so I have a whole lot of T-shirts from it. They sold T-shirts. It was like people submitted designs, and then everyone voted, and the top 3 designs got printed, and then they sold the T-shirts. So this was someone's design. But they haven't been around for a long time, and all of these shirts I think will soon have to be retired because they're not being replaced.
It's
it's
a cool shirt.
Different ones. Thanks.
All right, well, thanks for again for your time. Appreciate it, and good luck moving forward.
This was fun. Thanks.
I alone produce Brain Inspired. If you value this podcast, consider supporting it through Patreon to access full versions of all the episodes and to join our Discord community. Or if you want to learn more about the intersection of neuroscience and AI, consider signing up for my online course, Neuro-AI, The Quest to Explain Intelligence. Go to braininspired.co to learn more. To get in touch with me, email paul@braininspired.co. You're hearing music by The New Year. Find them at thenewyear.net. Thank you for your support. See you next time.